Influence of gravity experiment. Life on Earth has mainly been restricted from Isaac Newton's discovery, gravity. With the beneficial discovery of gravity, we have learned that gravity is a force of nature which pulls any object back on Earth. This is the same force that keeps us on the planet and keeps the moon orbiting around the planet. It is this natural force that keeps the balance of everything in the universe together. Although it is the weakest of the four known natural forces, gravitational, electromagnetic, strong nuclear, and weak nuclear, it is the most dominant. Majority of people have experienced running or cycling downhill in a considerably faster pace than on flat terrain. The extra speed comes from gravity, which draws the object towards its strongest point. As the hill may become steeper, you are in line with the center of gravity, thus overcoming friction and accelerating at a faster pace. This acceleration can assist when you need to go uphill. Over time, when an object is going uphill, the speed will decelerate and eventually be pulled back on Earth. In this experiment, we will be investigating this phenomenon where gravity produces energy and converts it into energy that allows an object to go uphill. The aim is to investigate how the force of gravity influences the distance of a ball rolling down and uphill. Hypothesis: when the ball is going uphill, the ball will travel the furthest when the angle of the uphill ramp is at its lowest degree. Hypothesis: when the ball is going downhill, the ball will travel the furthest when the ball is rolled on a ramp of around 40 to 50 degrees. Method: Part 1. Step 1. Set up the two ramps 1.5 meters apart. Step 2. With the protractor, measure the ramp which the ball will roll down with a constant angle of 30 degrees. Measure the other ramp to have an angle of 10 degrees. Step 3. Roll the ball down the 30 degrees ramp and measure the distance of how far the ball rolls onto the other ramp. Repeat this process with 3 trials. Work out the average from the result. Step 4. Increase the angle of the second ramp by 10 degrees and repeat step 3. Continue to do this until you reach 90 degrees on the second ramp. Part 2. Step 1. Set up the two ramps 1.5 meters apart. Step 2. With the protractor, measure the ramp which the ball will roll off of with an angle of 15 degrees. Measure the ramp which the ball will roll onto with an angle of 30 degrees. Step 3. Roll the ball down the 15 degrees ramp and measure how far the ball rolled up the second ramp. Repeat this process with 3 trials. Work out the average from the results. Step 4. Increase the angle of the first ramp by 15 degrees and repeat step 3. Continue to do this until you reach 90 degrees on the first ramp. The result of the first part of the experiment, where the ball rolls onto the ramp, shows a polynomial trend line. The results imply that the ball travels the furthest upwards when the ramp is at its lowest point. This is the case as the ball isn't going against gravity as much as angles of 20, 30, and 40 degrees. As the angle of the ramp increases, it becomes steeper and means that the ball will have to go uphill faster while also going against gravity. Whilst the logic behind the results are accurate, there may have been an occurrence of random errors. As the experiment was presented outside, wind may have made an impact to the speed of the ball by decreasing its velocity. This could have been avoided by doing the experiment within an enclosed environment. The result of the second part of the experiment, where the ball rolls off of the ramp, also shows a polynomial trend line. The ball travels the furthest distance up a hill when the ball rolls off of a ramp of 45 degrees. This is the case because if the ramp were to be vertical, the ball entirely relies on the force of gravity and will enter a free fall, where gravity constantly accelerates an object. While free fall accelerates the speed of an object, it does not allow the object to cover much distance, hence the outcome of 75 degrees to 90 degrees. On the other spectrum, when the ball is at 15 degrees, the ball will not utilize gravity, thus not accelerating and covering much distance. Hence, the 45-degree ramp is perfect for traveling distance at a decent speed as it takes advantage of gravity while not using too much of it to enter a free fall. Like the first part of the experiment, wind may have interrupted during the experiment and could have been avoided by doing the experiment in an enclosed environment. From this experiment, we have learned that the ball travels the furthest uphill when the angle is 10 degrees and will travel the furthest downhill when it is at an angle of 45 degrees. Overall, the hypotheses agree with the results from the experiment, which states that an object will travel a further distance when it goes downwards at an angle of 45 degrees and goes upwards at a low angle.